Throughout humanity's long journey of exploring the universe, the moon has always been the celestial body closest to us and the easiest to interpret. Since the last Apollo astronaut left the lunar surface in 1972 for 53 long years, the entire world had habitually defined the moon as a geologically dormant, monotonous gray satellite, believing that all internal activity had long since ceased and that its surface features had been fully mapped by various probes. As if humanity had already unlocked all of this celestial body's secrets, this seemingly solid and deeply ingrained perception was completely shattered on April 6, 2026, as the Orion spacecraft carrying 4 astronauts flew past the moon's permanently shadowed side. The series of entirely new sights it observed overturned humanity's half-century-old assumptions within just a few hours. We were suddenly made to realize that the unknowns hidden by the moon far exceeds what we already know. The crew carrying out this groundbreaking lunar mission was the Artemis II flight crew, consisting of Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen. This team holds epoch-making significance in the history of human spaceflight. For the first time, humanity has sent a female astronaut, an African-American astronaut, and a non-US citizen together into deep space beyond Earth's orbit. Breaking the mold of crew composition for previous deep space exploration missions, at 6:35 p.m. on April 1, 2026, the 4 crew members successfully launched from the Kennedy Space Center aboard NASA's Space Launch System SLS, the most powerful rocket the agency has ever built. Standing 322 feet tall, this colossal rocket generates 8.88 million pounds of thrust during liftoff. With a single-engine ignition lasting less than 5 minutes, it propelled the Orion spacecraft completely out of Earth's orbit. From the moment this ignition concluded, the spacecraft embarked on an unstoppable journey into deep space, with no possibility of turning back. The flight path adopted for this mission is defined as a free return orbit. The core objective of this orbital design is to maximize the safety of the astronauts, even if the spacecraft's main engines were to fail completely after leaving Earth's orbit. The moon's gravitational pull would naturally guide the spacecraft to complete a lunar flyby and subsequently return it automatically toward Earth. The Apollo 13 mission, which encountered severe equipment failures in 1970, relied precisely on this type of orbit to ensure the astronauts' safe return. This fact also underscores that space missions traveling between Earth and the Moon remain fraught with unknown risks. The so-called safest flight plan is, in essence, designed to address the most extreme contingencies such as a complete engine failure. When the Orion spacecraft entered the far side of the moon at an altitude of approximately 467 miles above the lunar surface, the 4 astronauts aboard became the most isolated group in human history. For a full 40 minutes, the moon itself completely blocked all radio communication between the spacecraft and Earth. Control commands from the Houston Mission Control Center, the spacecraft's telemetry data, and emergency response instructions were all interrupted. Only utter silence remained in space, while the oldest and most frequently impacted terrain in the solar system stretched out endlessly beneath the spacecraft. Before the communication signal was cut off, mission pilot Victor Glover attempted to describe the scene before him in real time to the ground control center, only to discover that ordinary language was utterly incapable of conveying the awe-inspiring impact of what he was witnessing. In his radio transmission, he remarked that the human visual perception system might not have evolved to the point where it could fully adapt to such a scene. The geological features of this region had already transcended the boundaries of everyday language. At 6:44 p.m. Eastern Time, communication was completely lost, with all contact to Earth severed. The 4 astronauts found themselves in the company of the mysterious landscapes of the far side of the moon. What they witnessed with their own eyes became the most valuable first-hand observational data in the history of lunar exploration, filling a half-century-long gap in on-site observations. To truly understand the awe and bewilderment that the far side of the moon inspires in humanity, one must first clearly distinguish the vast geological differences between the moon's near side and far side. The near side of the moon, visible every night in Earth's night sky, is dotted with vast dark plains known as lunar maria. These regions are basaltic plains formed billions of years ago when ancient lava flows filled giant impact craters and then cooled and solidified. Volcanic rock covers 31% of the near side's total surface area and constitutes the familiar lunar landscape that humans have known for millennia. In stark contrast, the lunar maria are extremely rare on the far side of the moon, accounting for less than 1% of its surface here. There are no flat, smooth lava plains. Instead, the landscape is dominated by layers upon layers of craters. Newer impact craters overlay older ones, while even more ancient craters lie buried beneath even older geological strata. It is as though, over the course of 4 billion years, relentless external forces have pounded this land, leaving behind a surface scarred by countless impacts. Scientific data indicates that the crust on the far side of the moon is approximately 50 kilometers thicker than on the near side. To this day, the scientific community has not reached a consensus on the cause of this significant difference. The widely accepted hypothesis among scientists posits that a catastrophic asteroid impact occurred near the moon's south pole in ancient times. The immense energy released by this impact generated a heat wave that continued to circulate within the moon's interior, pushing rare Earth elements and radioactive materials toward the moon's near side. This violent collision also created the largest impact structure in the solar system, the South Pole Aitken Basin. The basin has a diameter of approximately 2,500 kilometers and a maximum depth of 13 kilometers. If placed on a map of the United States, it would completely cover the entire area from Texas to Virginia. The mountain ranges along the basin's rim reach altitudes of up to 8 of 500 meters, ranking among the moon's highest peaks. Beneath the surface of this basin lies a massive object capable of overturning existing lunar theories. In 2019, Peter James, a planetary geophysicist at Baylor University, led a research team that combined gravity data from NASA's Grail mission with topographic mapping results from the Lunar Reconnaissance Orbiter. They discovered a distinct mass anomaly at a depth of at least 300 kilometers beneath the South Pole Aitken Basin. The minimum mass of this high-density material reaches 2.18 quadrillion kilograms. James vividly likened it to burying metal, equivalent to the volume of 5 Hawaiian islands deep beneath the moon's surface. The mass of this material is sufficient to pull the basin's surface downward by more than half a mile. The scientific community generally infers that this is the metallic core of the asteroid that formed the basin during the impact billions of years ago, which has remained embedded in the lunar mantle throughout the long span of 4 billion years, much like metal fragments trapped within a living organism that cannot be metabolized and expelled. The astronauts aboard Artemis II are the first humans to witness the eastern rim of this basin with their own eyes. Unlike the mechanical imagery and post-processed data transmitted by probes, they observed this unique landscape directly through the spacecraft's windows with human eyes. In contrast, none of the Apollo mission crews ever saw this region firsthand due to limitations in flight path planning and lighting conditions. The flight path of Artemis II was meticulously planned, allowing the spacecraft to fly by the far side of the moon at a closer distance and from a more favorable angle. This enabled the astronauts to observe approximately 21% of the far side under direct sunlight, marking the first time humans have witnessed these previously unseen topographic features with their own eyes. This lunar flyby mission has identified 30 scientific observation targets, one of which is the Oriental Basin. This 3.8 billion-year-old impact basin, with a diameter of nearly 600 kilometers, spans the boundary between the moon's near and far sides. Viewed from orbit, it resembles a bullseye structure embedded along the western edge of the moon. Since the crew members were all professional pilots and engineers, rather than specialized geological researchers, they underwent several months of specialized training in volcanic landscapes, such as those in Iceland, to learn how to identify and accurately describe various lunar geological features in real time. During the observation, Christina Cook discovered that, compared to the ancient lunar surface surrounding them, the smaller, younger impact craters stood out strikingly in brightness. She likened them to tiny pinholes in a lampshade, emitting a strikingly bright white light against the dim lunar surface, before reaching the far side of the moon. The astronauts also conducted focused observations of a mysterious geological feature on the near side, the Rinaldo Gamma Bright Streak region. This swirling pattern of bright streaks spans the lunar surface, appearing as if someone had painted white lines on dark rock. It lacks significant topographical variations. It is neither an impact crater formed by celestial collisions nor a sedimentary feature left by volcanic activity, but rather a flat optical marker that perfectly coincides with a localized magnetic anomaly in the underlying crust. Although the moon lost its global magnetic field billions of years ago, some magnetized rocks remain in its crust, like faint imprints left behind after the ancient magnetic field vanished. The Rinaldo Gamma region happens to lie directly above one of these magnetized zones. Scientists have yet to determine whether the bright streaks formed because the magnetic field shielded the area from solar wind erosion, or if there are other as-yet undiscovered causes. The Artemis II science team has listed it as a priority observation target, and the astronauts captured a large amount of high-definition imagery during the flyby. Victor Glover showed great interest in observing the lunar terminator, the boundary between day and night on the moon, which continuously shifts as craters near the terminator exhibit completely different visual characteristics. As sunlight skims the crater rims at an extremely low angle, it casts shadows of profound depth, resembling hollow passages leading directly to the moon's core. In his radio communications, Glover described the scenery near the terminator as fantastical, with bright highlands and pitch-black shadowed valleys intertwining, akin to a black hole structure capable of pulling one straight into the moon's center. Meanwhile, Christina Cook and Jeremy Hansen continued to photograph the Vavilov crater deep on the far side of the moon, which lies on the edge of the older and larger Hertzsprung basin. The scientific assessment team in Houston dynamically adjusts the observation plan based on the astronauts' real-time reports, sending the latest observation commands to the spacecraft to ensure the maximum acquisition of valuable scientific data from the far side of the moon. The astronauts also discovered subtle features not fully captured by orbital probe imagery, rich color variations on the lunar surface. On the near side, shades of brown and green of varying intensity are visible, and some areas even exhibit a faint blue halo. These subtle color differences can be accurately detected by the human eye, but are often smoothed out during the camera imaging process. Since these color variations are directly linked to the mineral composition of lunar surface materials and the age of terrain formation, this new field observation data is sufficient to rewrite existing theoretical models of lunar geological evolution. Such observations are not merely visual impressions, but reveal numerous anomalous geological phenomena on the far side of the moon. In 2023, researchers detected a thermal anomaly zone beneath the lunar surface. This area, approximately 50 kilometers wide, had a temperature about 10 degrees Celsius higher than the surrounding surface. After in-depth analysis, researchers concluded that a massive granite body is buried beneath this region. While such rock is extremely common on Earth, its formation requires ample liquid water and plate tectonics, two conditions entirely absent on the moon, making the presence of granite highly anomalous. The research team speculates that this may be the remnant of a volcano that went dormant 3.5 billion years ago, with residual magma beneath the surface still slowly emitting faint heat. Matt Siegel, the lead scientist of the study, stated that the geological features revealed by this discovery are far closer to Earth's geological environment than previously imagined, raising a new, critical question. Just how many similar thermal sources remain undiscovered deep beneath the moon's surface? In addition to these subsurface thermal anomalies, the moon's lava tubes represent another major unsolved geological mystery. Radar data and high-resolution remote sensing imagery reveal a network of underground tunnels within the moon's interior, formed by ancient lava flows. Orbital probes can clearly observe the entrance craters to these tunnels, and the scale of these underground spaces may be immense, potentially large enough to accommodate large-scale scientific research facilities built by humans. However, humanity currently knows nothing about the true size, distribution, or structural stability of these lava tubes, whether they contain special gases, primordial volcanic sediments, or temperature environments vastly different from the surface remains purely theoretical speculation. Future Artemis missions may include the exploration of lava tubes in their official plans, but at this stage, these underground spaces remain completely sealed off, harboring countless unknown secrets during the flyby of the lunar far side. The Artemis II crew also witnessed an astronomical phenomenon never before observed by humans from such a close perspective, a total solar eclipse from lunar orbit. As the Orion spacecraft entered the moon's shadow, the sun was completely obscured by the lunar disk. This total solar eclipse lasted nearly 54 minutes, far exceeding the duration of any total solar eclipse observable from Earth. Victor Glover described how the sun's corona formed a bright halo around the moon, bright enough to encircle the entire lunar body. Jeremy Hansen noted that during totality, sunlight illuminated the moon's entire rim, casting the lunar ridges and peaks as sharp silhouettes against the white light of the sun's atmosphere. Both Hansen and Reed Weissman observed impact flashes on the lunar surface, brief bursts of light most likely caused by small meteorites striking the unprotected far side of the moon. Both confirmed seeing at least one such flash, but were unable to determine its exact duration. The moon has no atmosphere and no complete global magnetic field to protect it. Its surface is directly exposed to various potential threats from space, with micrometeorites, solar wind particles, and galactic cosmic rays bombarding the far side's surface unimpeded for centuries. Observers on Earth have repeatedly reported brief flashes of light on the lunar surface. These phenomena, known as transient luminous events, appear and vanish rapidly, and have never been effectively verified on the ground. Some of these phenomena result from meteorite impacts, while others may be caused by electrostatic dust plumes or gas eruptions from within the moon. The exact causes remain unclear to this day, and the flashes observed by the Artemis II crew during the solar eclipse are likely a genuine manifestation of such mysterious phenomena. As far back as the Apollo program, astronauts on missions to the near side of the moon reported seeing mysterious patterns of light when they closed their eyes, a physiological reaction caused by high-energy particles from galactic cosmic rays penetrating the retina. Although Apollo astronauts were exposed to radiation in space for only a few days, many developed cataracts prematurely later in life. While most astronauts lived long lives and did not develop radiation-related cancers, only 24 astronauts ever left the protective range of Earth's magnetic field, a sample size that is simply too small to be statistically significant. The Artemis II crew will need to remain in deep space for 10 days, and the mission coincides with the solar maximum, the phase of the sun's 11-year activity cycle with the highest radiation risk. A single high-intensity solar storm could cause space radiation levels to reach near-lethal levels within a matter of hours. While the Orion spacecraft offers far superior radiation protection compared to the Apollo series, galactic cosmic rays, originating from violent cosmic events such as supernova explosions, travel at speeds approaching the speed of light and can penetrate the vast majority of human-made protective equipment. Alexandra Stankovic, founding director of the Center for Space Medicine at Massachusetts General Hospital, points out that deep space radiation is the core obstacle limiting the scope of human deep space exploration and can be described as a fatal barrier to crewed space exploration. To address this challenge, researchers are testing various biological protection strategies, ranging from experimental protective drugs and nutritional supplements to gene editing technologies inspired by radiation-resistant organisms. Since enabling humans to operate long-term in deep space beyond Earth's magnetic field requires more than just physical shielding from spacecraft, biological protection measures are indispensable. Among the dedicated experimental payloads carried by Artemis II are bone marrow cells extracted from the crew's blood. After the mission concludes, researchers will analyze the damage and changes these cells have undergone in the deep space radiation environment. The scientific value of this data far exceeds that of any lunar imagery. During the 40-minute communication blackout, the 4 astronauts were completely isolated and helpless. If a solar particle flare had occurred at that moment, the ground control center would have had to wait until the signal was restored to learn the specifics of the situation. Although the crew had undergone professional emergency response training, and the spacecraft was equipped with a continuous oxygen supply system and pressurized spacesuits capable of handling sudden cabin damage or malfunctions, these safety measures could not alter the dangerous situation they faced. The 4 were trapped in a cramped cabin, roughly the size of a large van, separated from Earth by 160 miles of lunar rock. In a desolate environment riddled with ancient impact craters, and exposed to deep space radiation that the human body has not evolved to withstand. The moment communication was reestablished, the Houston Mission Control Center erupted in excitement. The astronauts reported to ground control that they had witnessed Earth slowly sinking below the lunar horizon. The pale blue planet, shaped like a crescent, gradually disappearing behind the gray. Crater-covered lunar surface. This image of Earth setting, released by NASA, forms a perfect mirror image of the Earthrise photograph taken by the Apollo 8 astronauts in 1968. The difference is that this time Earth is gradually receding, slowly disappearing behind the shadows of the far side of the moon. Christina Cook described her inner feelings at that moment in simple, heartfelt words. Only by looking back at Earth from the unique vantage point of the far side of the moon can one deeply appreciate the preciousness of our shared home. Earth provides all the resources and conditions necessary for human survival, and this profound realization can only be truly grasped from the special perspective of the moon's far side. During the flyby of the far side, the crew officially named 2 lunar craters. One was named Signal Crater after the Orion spacecraft's nickname, and the other was named Carroll Crater in memory of Carroll Taylor Weissman, the wife of Reed Weissman, who passed away in 2020. Located at the boundary between the moon's near and far sides. This crater is visible from Earth as a bright surface feature when viewed from the right angle. Jeremy Hansen simply described it as a bright spot on the lunar surface. The Artemis II mission also set a record for the farthest distance humanity has traveled from Earth, reaching approximately 252,756 miles. As the spacecraft flew past the moon's perigee, its relative speed relative to Earth reached 6,863 miles per hour. The entire observation of the far side of the moon lasted 7 hours. The astronauts captured thousands of high-resolution photos. Due to limitations in interplanetary communication bandwidth, most of the imagery has not yet been transmitted back to Earth. The complete image set will be officially released on April 10 after the spacecraft splashes down off the coast of San Diego. These on-site images hold immense scientific value. NASA stated that high-resolution photographs of craters, ridges, and ancient lava flows will help researchers gain deeper insights into the moon's formation and the evolutionary history of the solar system, while also providing critical data for site selection for future crewed lunar missions under the Artemis program. Astronauts' on-site descriptions of topography, shadow distribution, and surface textures hold greater practical significance than remote sensing data from probes. Many areas that appear flat and safe in orbital imagery reveal hidden terrain hazards when observed by the human eye against the backdrop of the Terminator's shadows, a factor directly impacting the landing safety of future lunar missions. Today, the far side of the moon has become a focal point of global space research and exploration. Although no political territorial disputes have yet emerged, competition in the realm of scientific exploration has long been quietly underway. In January 2019, China's Chang'e 4 lander successfully achieved a soft landing in the von Karman crater within the South Pole Aitken Basin, the first ever soft landing on the far side of the moon in human history. Since direct radio communication with Earth is impossible from the far side, the mission relied on the Qichao relay satellite to transmit signals. The Yutu-2 lunar rover detected lunar mantle minerals, such as olivine and pyroxene on the far side of the moon, confirming that the impact depth of the South Pole Aitken Basin is sufficient to expose material from hundreds of kilometers below the lunar surface. In 2024, the Chang'e 6 mission took things a step further by collecting soil samples from the far side of the moon and returning them to Earth. This marked the first time humanity has brought material from the far side of the moon back to a laboratory for detailed analysis, and related scientific research is still ongoing. In addition, the far side of the moon offers a unique scientific advantage within the inner solar system, an environment of absolute radio silence. The moon's 300-400-kilometer thick rocky core completely shields the region from all forms of electromagnetic interference from Earth. Neither mobile phone signals, radio and TV broadcasts, nor Wi-Fi radiation can penetrate to the far side for radio astronomers. This is the world's most ideal observation platform. Setting up telescopes on the far side of the moon allows for the detection of low-frequency signals below 30 MHz that are blocked by Earth's ionosphere, opening a brand new window for observing the early universe. Space agencies from multiple countries have proposed plans to build deep space observatories on the far side of the Moon. The Moon not only harbors countless geological secrets beneath its surface, but also provides a natural, high-quality observation platform for humanity to explore the far reaches of deep space. Human understanding of the Moon has long been marred by a serious problem of drawing sweeping conclusions from limited data. Although we have achieved the feat of 6 crewed lunar landings, all activities were confined to a few regions on the Moon's near side. Constructing a theoretical model of the Moon's entire evolutionary history based solely on limited samples and observational data is as one-sided as landing a probe in the Sahara Desert and hastily concluding that the entire Earth consists of sandy terrain. The far side of the Moon is the core region that records its true evolutionary history. Its terrain is extremely ancient, preserving ancient impact craters that were completely erased on the near side after being covered by lava. The immense scale of the South Pole Aitken Basin is sufficient to influence the Moon's rotational axis. Subsurface metal anomalies distort the local gravitational field. Unexplained thermal anomalies, sealed lava tubes, and crustal structures with varying thicknesses all continually challenge existing theories of lunar formation and evolution. After the spacecraft departed from the far side of the Moon and Earth reappeared in view, Victor Glover remarked that the Moon is not merely an insignificant decorative backdrop in the sky, but a real celestial body brimming with unknown mysteries. This statement captures the core truth of human lunar exploration. The more we learn about the Moon, the more we realize the narrowness and limitations of our own understanding. Discoveries on the far side of the Moon continue to overturn previous scientific conclusions. Granite intrusions that shouldn't exist, unexplained mass anomalies, the mystery of the crust's asymmetry, traces of magnetization left by a vanished magnetic field, and shallow moonquakes detected by Apollo seismometers. All of these fully demonstrate that the Moon is not a completely lifeless planet, and that faint geological activity still persists within it. Every new discovery on the far side of the Moon gives rise to more unanswered questions, and these questions are increasingly touching upon the core secrets of the Moon's evolution currently. The Artemis II crew has embarked on their return journey, flying toward Earth at thousands of miles per hour, and is about to complete a splashdown recovery in the Pacific Ocean. What they bring back are the first on-site observational results of the far side of the Moon in over half a century, not algorithmically processed probe images, but real-world scenes that even veteran astronauts with 168 days of space station experience admit transcend the limits of human perception. This natural satellite, which has accompanied Earth for billions of years, has completely shattered humanity's preconceived notions. We once believed we had fully understood the Moon. But in reality, humanity's exploration and understanding of it has only just taken its very first step. The countless cosmic mysteries and geological truths hidden within the Moon still await subsequent space missions to unveil one by one, and humanity's journey into deep space will become even more resolute and determined thanks to this epoch-making lunar flyby mission.